The next exponent rule that we'll look at is the power of a power property. You can see here in the rule, if you have a to the m, and then you take that and you raise it to the nth power, you end up with a to the mn. So in words, this means that you keep the same base and you multiply the exponents. Let's do an example to see why it works out this way. So let's say that we had y squared raised to the fourth. Again, remember the definition of an exponent. It is repeated multiplication. So when you see something raised to the fourth power, it means multiply that thing by itself 4 times. So this means y squared times y squared times y squared times y squared. And then remember that y squared means y times y. So each of these y squareds is going to become a y times y. And then if we count those up, we've got 1, 2, 3, 4, 5, 6, 7, 8 y's. So y multiplied by itself 8 times is y to the 8th by just the definition of exponents. And rather than writing all of that out, we can go back to this rule where we multiply the exponents. So y squared to the 4th would be y to the 2 times 4, or y to the 8th. Let's do a few more examples. So for number 1 here, we have z to the 4th to the 5th. So it's a power raised to a power in which we keep the same base and we multiply the exponents. So we keep the z and we do 4 times 5, which is 20. So our solution is z to the 20th. For number 2, the base is a 2, so we keep the 2 and we multiply the exponents, and we get 2 to the 6th. Now because the base is a numerical value, you could put this into your calculator. 2 to the 6th equals 64, but it's probably just easier to keep it as 2 to the 6th, although 64 is also correct.